Everyone, welcome back to my channel. In this video lecture we will cover a new chapter of physics, that is waves. So let's begin with today's video. Few basic concepts of waves: wavelength, distance between the same points on two consecutive waves; amplitude, distance from equilibrium line to the maximum displacement; frequency, the number of waves that pass a single point per second; period, the time taken for a whole wave to completely pass a single point; velocity is equal to frequency into wavelength; period is equal to 1 upon frequency, where the period t in seconds, s, and frequency f in hertz. Relationship: physics only. Increases frequency, velocity increases; wavelength increases, velocity increases; period is inversely proportional to frequency; smaller period, higher frequency, greater velocity. Types of wave: transverse waves and longitudinal waves. Measuring sound in air, ripples on water surface. Then interactions: wave can reflected, absorbed, or transmitted at the boundary between two different materials. Reflections: wave will reflect off a flat surface. The smoother the surface, the stronger the reflected wave is. The angle of incidence is equal to the angle of reflection. Then sound waves can travel through solids, causing vibration in the solid. The outer ear collects the sound and channels it down the ear canal. As it travels down, it still is a pressure air wave. The sound waves hit the eardrum. Then vibrations of the bone transmitted to the fluid in the inner ear. Compression waves are thus transferred to the fluid. The limitations: human cannot hear below 20 Hz or above 20 kHz. In the cochlea, the hairs attune to the higher frequency die or get damaged. We have evolved to hear this range of frequency as it gives us greatest survival advantage. Ultrasounds: when ultrasound reaches a boundary between two media, they are partially reflected back. The remainder of the waves continue and pass through. Infrasound is the opposite of ultrasound. It is a sound wave with frequency lower than 20 Hz, also known as seismic waves. Then electromagnetic waves, they are transverse waves, do not need particles to move. In space, all waves have the same velocity. They can transfer energy from a source to absorber. For example, microwave source to food. Sun emits energy to the earth. Relationships: as speed is constant for all EM waves, wavelength decreases, frequency must increase. Frequency increases, energy of the wave increases. Then refraction: if entering a denser material, it bends towards the normal. If entering a less dense material, it bends away from the normal. Then atoms and EM radiation: when electron charge orbit, when electron moves to a higher orbit, when electrons falls to a higher orbit. Then lenses: if light passes through center of the mass, it does not change its direction. Lenses are generally drawn as the dashed vertical line. Then concave lenses: a concave lens scales inward. They are thinner at the center than at edges, spread light outwards. Convex lens: a convex lens is normally wider at center. They focus light inwards. Horizontal rays focus onto focal point. Then visible lights: each color within visible light spectrum has its own narrow band of wavelength and frequency. Types of refraction: specular and diffuse. Color filters: this works by a filter absorbing every other color and only letting certain wavelength through. Black body radiations: a body at the all objects regardless of the temperature emit and absorb infrared and radiation. The hotter the body, the greater amount of radiation released per second, and the hotter the body, the greater amount of shorter wavelength radiations are released. Earth: sun's energy is mostly absorbed by the earth's atmosphere and some is reflected. The amount of energy re-radiated and absorbed leads to earth's temperature. So this much for today's video. Hope you liked it and understood it. Thank you for watching my video, and don't forget to like, share and comment my videos, and don't forget to subscribe my channel. Thank you.